Firms in competitive markets. We're going to start using some concepts that we covered previously to see how firms make production and pricing decisions in different market structures. In this chapter, we're going to explore firm behavior under perfect competition. Future chapters cover the extreme end of the competition spectrum, the monopoly, for example, and also monopolistic competition and oligopoly. Those latter cases are intermediate cases, talking about oligopoly and monopolistic competition. Again, the extreme is monopoly, the intermediate is oligopoly and monopolistic competition, but in this chapter, we're going to talk about competitive markets. So, introducing this as a scenario, let's say 3 years after graduating business, or graduating with a business degree, you run your own business. You must decide how much to produce, what price to charge, and how many workers to hire, and so on and so forth. What factors should affect these decisions? Your costs, which are studied in the preceding chapter to this one, and how much competition you face are two things to consider. We begin by studying the behavior of firms in a perfectly competitive market. So what is a perfectly competitive market? Well, characteristics of perfect competition are threefold. There are many buyers and many sellers. The goods offered for sale are largely the same, so they can be perfectly substitutable. And firms can freely enter or exit the market. Because points 1 and 2, each buyer and seller, because of points 1 and 2, each buyer or seller is a price taker. They're not a price decider. They're not a price giver. The market gives them a price as a buyer and as a seller. They say, this is the price you're going to pay. They have to take the price as given. So firms can freely enter or exit the market. This means that there are no barriers or impediments to entry. For example, the government does not restrict the number of firms in a market. Now, when looking at competitive firms in revenue, total revenue is very simple. It's just price times quantity. The price you get times the quantity you sell. Average revenue is very simple as well. Take your total revenue and you divide it by the quantity that you sell. Now, in a perfectly competitive market structure, total revenue divided by quantity is also price. So average revenue equals the price. It's the per unit revenue that you get. Again, that's average revenue, and the per unit revenue that you get in a competitive market is the price. Marginal revenue, MR, is the change in total revenue from selling one more unit. Again, marginal, you think of one more unit, so the revenue you get from selling one more unit. Well, that's that delta TR over delta Q, which is the change in total revenue given a change in quantity. So if your quantity goes up by 1, what is the change in total revenue? And the resulting, the result of that is your marginal revenue. So these revenue concepts are analogous to cost concepts that we covered in the previous chapter, namely total cost, average total cost, and marginal cost. Now, calculating total revenue, average revenue, and marginal revenue, we're going to look at the empty spaces in a table. This is a relatively easy exercise. If you want to pause the lecture right now and work your way through this, we're going to move forward to the answers here in a moment. You can apply the definitions that you got in this previous slide. We did something like this with cost in the previous chapter. So this exercise also demonstrates that marginal revenue equals marginal price for a competitive firm. This table is similar to the exercise in table 1 in the reading of the chapter. So you can actually practice it twice. So go ahead and press pause, work through this, and we'll move on to the next slide. And you can also do it in the reading as well. So here are the answers. We fill in the empty spaces from the table. Notice that marginal revenue here equals price, okay, in this competitive situation. So that fulfills the previous the previous slide where we were talking about marginal revenue and price being similar, so or being the same, I should say. So the price is fixed at $10. These red areas are the ones we went to fill in. Total revenue is simply price times quantity, so that's a very simple calculation. Average revenue is simply total revenue that you calculated here divided by quantity, which is given here, so you can calculate that. And then marginal revenue is nothing more than the change in total revenue divided by the change in quantity. So you had a change from 0 to 10, and you had a change from 0 to 1, so the change in total revenue is 10, and the change in quantity is 1, The marginal revenue is 10, and that happens to be constant throughout this calculation. Okay, so marginal revenue equaling price for a competitive firm. A competitive firm can keep increasing its output without affecting its market price. So each 1 unit increase in quantity causes revenues to rise by price. For example, marginal revenue equals price. Marginal revenue equals price, you must remember this point, is only true for firms in competitive markets. It's not going to happen in other markets where we have less than competitive situations like monopoly, monopolistic competition, or oligopoly. That will not hold. So that is only something that you see in perfectly competitive markets. Now, profit maximization. What quantity maximizes the firm's profit? To find the answer, we have to think at the margin, going back to chapter 1. If quantity increases by 1 unit, revenue rises by marginal revenue. So again, we have that. What is that revenue we get from producing 1 more unit? Well, cost also rises by marginal cost. What is my cost for producing 1 more unit? Well, if marginal revenue exceeds marginal cost, then the increase in quantity raises profits. If marginal revenue is less than marginal cost, means your costs are outstripping your revenues you get, then reduce the quantity to raise profit. One adds more revenue and one lowers costs. Okay? If your costs are greater than your revenue, stop producing. If your revenue is greater than your marginal cost, keep producing. Very simple. Now, continue from the earlier exercise looking at profit maximization. At any quantity where marginal revenue is greater than marginal cost, increasing quantity will raise profit. Now, conversely, at any quantity where marginal revenue is lower than marginal cost, reducing the quantity raises the profit. So we have our quantities here, we have our total revenues, we have our total costs here, we have our profit that we're looking at here. We have total costs. Let's say this must be a fixed cost that we have to pay either way, whether we produce or not. Our profit's minus 5. We have a total cost here of 9. Our profit's 1, then 5, then 7, then 7, and then we go up to 5. Well, our marginal revenues, again, that we calculated before in the previous examples, is set at 10. And our marginal cost, when we're looking at the additional cost to produce 1 more good, we move from a total cost of 5 to 9 is $4. We move from a total cost of 9 to 15 is $6, and so on and so forth, all the way from 33 to 45, which results in a marginal cost of 12. Well, we're looking at what's greater, marginal cost, or marginal revenue, or marginal cost. What's greater? In this case, our profit's 10 because our marginal revenue is 10, and a marginal cost is 6, or our profit is actually 6, I should say. So marginal revenue minus marginal cost is your change in profit. Again, your change in profit, not total profit. We have marginal revenue still exceeding marginal costs here. Okay, so we're going from 1 to 2. Going from 2 to 3, marginal revenue still exceeds marginal cost, so we're still making more money than it's costing us to produce 1 more. Now here we have a break even. It seems like a good place to stop. Now, as a rule of thumb, you can remember this for all markets. You're going to want to operate where marginal revenue equals marginal cost, okay? Because you've garnered all the additional revenue. Once marginal revenue equals marginal cost, what's going to happen next? Well, you're right. If you remember the fact that the marginal cost curve is shaped like that Nike swoosh, well, what's happening in Nike swoosh as it goes up? Cost is going up. So once they equal, do you think if you add 1 more unit, you're going to have marginal revenue that's greater than marginal cost? No, you're going to have marginal cost greater than marginal revenue, which is exactly what happens when you move from a quantity of 4 to 5. Your costs overtake your revenue. There's no more revenue to be had. There's no more juice in the orange. So producing more actually increases your costs and reduces your profits. So your change in profit actually goes down. So once your change in profits equals 0, your marginal cost equals marginal revenue, and you've pretty much, well, no, you haven't pretty much, you have maximized your marginal revenue, and you're about to start taking on a loss. Initially, this can be a little too much at once for you. However, it's going to be something that we're going to repeat in this course so much moving forward, you'll be very, very used to it. So, a marginal cost in a firm's supply decision. The rule here is marginal revenue equals marginal cost at the profit maximizing Q. Okay. We have a marginal revenue here. We have a marginal cost, a very simplified marginal cost curve. Doesn't necessarily look like the Nike swoosh that we're used to. This is a very simplified marginal cost curve that's vertical and a horizontal marginal revenue. Marginal revenues, in a competitive market situation, marginal revenue equals price. So it's simply the line at the price. You sell one more unit, this is your marginal revenue. You sell one more unit, this is your marginal revenue. You sell one more unit, this is your marginal revenue. All along this line. It's very constant. Now marginal costs, here your marginal revenues exceed. You see here on this line compared to the blue line, all the way up until this point, you have garnered all the marginal revenue you can get. What happens if you move beyond the marginal revenue? Marginal cost gets greater. Marginal cost is greater than marginal revenue. You start incurring costs. So at QA, marginal cost is less than marginal revenue at QA. Marginal cost is less than marginal revenue. So an increase in quantity will raise profit. At QB, marginal cost here is greater than marginal revenue, so reducing the quantity produced will raise profits because your costs exceed your revenues. At Q1, marginal cost equals marginal revenue, and changing Q would lower profit in either direction, either going this way and costs exceed revenues, or going this way and you leave some revenues on the table that are greater than your marginal costs. So think about this triangle area here. You want all of it. You want this whole slice of pizza. Okay, and if you don't go up to Q1 from QA, you're leaving a piece here. So you're leaving some profit here. Now, if you go over here, you're actually giving up some costs. Okay, see the costs exceed the revenues. So you always want to operate where marginal revenue equals marginal cost. Now here in this particular graph, I've omitted average variable cost and average total cost, which appear in Figure 1 in the chapter, because really to make this point, they're not needed. So this is a simplified version. You want to operate right where marginal cost equals marginal revenue. If you remember that, you just got some points on your test. So marginal cost in the firm's decision, supply decision. If price rises to P2 here, from P1 to P2, then the profit maximizing quantity rises to Q2. Why? Because you're getting more revenue. You're getting a higher price for your product. The marginal cost curve determines the firm's quantity at any price. Hence, in this example, where price equals marginal revenue, again, only true in competitive markets, the marginal cost curve determines where the firm's quantity at any price. Hence, the marginal cost curve is the firm's supply curve. Okay, upward sloping just like a supply curve. It's essentially their supply schedule. The marginal cost curve, again, in this example in the competitive market, is the supply curve. So we have our marginal revenue and marginal cost. When we increase price from P1 to P2, our where marginal cost equals marginal revenue increases from Q1 to Q2. Okay, this is the marginal cost. This is our new marginal revenue. This is where we want to operate. Okay, bigger slice of pizza, no? Okay, so making the decision to shut down or exit a market, so looking at shutdown versus exiting. A shutdown is a short-run decision not to produce anything because of market conditions. You just quit producing your output. An exit is a long-run decision to leave the market. So it's very important to discern between shutdown and exit in terms of long-run and short-run. Shutdown is a temporary short-run decision. A exit from a market is a long-run. We are leaving. We're no longer producing this type of type of product decision. So a key difference: if a shutdown is short-run, you must still pay the fixed costs. If it's an exit in the long run, there is zero cost. You're leaving the market altogether. Remember, fixed costs are fixed in the short run. In the long run, all costs are variable. So if you leave an industry in the long run, all the costs are variable. You don't incur those costs unless you voluntarily do so. So, very important concept in this chapter: a firm's short-run decision to shut down. Cost of shutting down is revenue loss. Is the revenue loss equal to total revenue? So the benefit of shutting down. So the cost is the revenue loss, and the benefit of shutting down is the cost savings, which is the variable cost. Firm must still pay the fixed costs in the short run. You still have to pay your rent in the short run. There again, in the short run, there are fixed costs. So the cost of shutting down is the revenue you forego, your total revenue you forego, and the benefit of shutting down is the cost savings. Now, so you shut down if your total revenue is less than your variable costs. Again, if what you're making as a business is less than your variable costs in the short run, shut that joker down. So we can divide both sides by Q to get a per unit version of total revenue versus total cost. So if total revenue per unit produced is less than the variable cost per unit produced, every time you produce one more unit, your variable cost is going to be higher than the revenue you produce. You're actually costing yourself more money by continuing to produce more units. So in this scenario, the firm's decision rule is to shut down if the price is less than average variable cost. So again, price is equal to total revenue divided by quantity. Average variable cost is the variable cost divided by quantity. So in per unit terms, the total revenue you get per unit is price, and the average variable cost is your variable cost divided by the number of units you produce. So if the price that you're getting, the revenue you're getting, is less than the cost that you're paying to produce one more unit, shut her down. Now, a competitive firm's short-run supply curve. A firm's short-run supply curve is the portion, pardon me as I move this, is the portion of its marginal cost curve above the average variable cost. Okay. And what we'll do here is just go ahead and move these. So in the short run, the firm's short-run supply curve is the portion of its marginal cost curve that's above the average variable cost. Because if it's below the average variable cost, you're not going to produce. Okay? If the price is greater than the average variable cost, then the firm produces a quantity where P equals the marginal cost. So you're going to produce at this bottom out efficiency scale in the average total cost curve that we talked about in the previous chapter. We're going to produce where marginal cost equals marginal revenue, which is going to coincide with that efficiency scale is. You're going to produce this quantity. Imagine a dot down to this quantity. Now, if price is down here, it's lower than your average variable cost. The firm shuts down because as you produce more goods, each time you produce more, your costs are greater than your revenues. So it would just behoove you just to shut down and find a way to pay your fixed costs than digging yourself a deeper hole. So the irrelevance of sunk costs is an important concept. Sunk cost is a cost that has already been committed and cannot be recovered. Sunk costs should be irrelevant to decisions. You have to pay them regardless of your choice. You could just shut down your business and you still have to pay them. You could run your business, you still have to pay them. No matter what, they're a sunk cost. A fixed cost is a sunk cost. A firm must pay its fixed costs whether it produces or shut down. So if you have a scenario where you're trying to decide whether to produce, fixed costs should not matter in that decision to shut down. What should matter is if you can cover your variable costs. Because if you cannot cover your variable costs and you're operating down here at a price that's below your variable cost, you're actually digging your debt hole deeper, okay? As you produce more and more quantity, your average variable cost is going to go up, okay? So fixed cost is a sunk cost. You got to pay it either way. You need to decide if you're getting out of the hole or if you're digging the hole deeper. So a firm's long-run decision to exit, the cost of exiting the market is the revenue loss. Again, this is exit versus shutting down. This is like a long-run decision to exit the market. So if you exit the market, what you're giving up is your revenue. The benefit of exiting the market is the cost savings, so your total cost. Again, there is zero fixed cost in the long run. So if it's your benefit if your cost savings is greater than your revenue loss, you're going to exit. So if your total revenue is less than your total cost, you're going to exit. You divide both sides by Q to write the firm's decision rule, and you exit if your price is less than your average total cost. Again, if you're per unit, if you divide total revenue by Q, you get your per unit revenue, which in a perfectly competitive world is your price. So you sell one more unit, you get if your price is $5, you get $5 more. You sell one more unit, you get another $5, and so on and so forth. Versus your average total cost, which is nothing but total cost divided by quantity. So if your price is less than what you have to pay to produce, you exit the market. The decision rule for whether the exit basically says if the cost of exiting is greater than the benefit, then the firm should exit. So a new firm's decision to enter a market. Okay, so this is a brand new firm thinking about entering a market. In the long run, a new firm will enter the market if it is profitable to do so. So if the total revenue is greater than the total cost, if there's money to be made, they're going to enter. Firms will continue to enter a market until it's no longer profitable to enter a market. So you divide both sides by Q. Again, total revenue divided by Q, it puts in per unit terms. Total cost divided by Q puts in per unit terms. And express the firm's decision as in a competitive situation. If price is greater than average total cost, that means your per unit revenue is greater than your per unit average of total cost. That means you're making money, so you enter a market. A firm will enter a market. So a prospective entrant compares the benefits of entering a market, which is the total revenue, with the cost, which is the total cost, and enters if the benefits exceed the cost. Basically, if entry will be rewarded with profits, a firm will enter a market. So, a competitive firm supply curve. The firm's long-run supply curve is a portion of the marginal cost curve, again, that is above the long-run average total cost curve. So, this whole area here, you're below the long-run average total cost curve, so you wouldn't supply anything. You'd be losing money. You wouldn't be making any money, okay? So, supply curve is going to start above that long-run average total cost curve. Again, marginal cost curve in competitive situations synonymous with supply curve. So this area right here represents your firm's supply curve. So let's work through a learning activity. So let's identify a firm's profit. Determine this firm's total profit, and identify the area on the graph that represents the firm's profit. Okay, so take a moment to examine this graph, and then here in a second I'm going to move over to the answer. And think about the question, place it on pause, think about what you would say before proceeding to the next slide. Okay, here we go. So this rectangle here represents profit. Okay, we know from previously in this lecture and previous lectures that we're going to operate where marginal cost equals marginal revenue. Well, that's at a quantity of 50. So here the price, our marginal revenue again is synonymous with price. So here our price is $10, and we have an average total cost curve running here. Okay, when we operate where marginal cost and marginal revenue equal, we drop down. We see that's a quantity of 50. With a quantity of 50, we have an average total cost that falls right here at $6. Okay, so this rectangle. Everything above $6, so everything $6 to $10, and from 0 to 50 quantity is our profit. This area literally is the amount of profit we're going to make. So profit per unit is nothing more than price minus the average total cost. Remember, price is your marginal revenue per unit, and average total cost is your cost per unit. So $10 minus 6, your profit per unit is $4. Okay. Total profit is again this price minus average total cost, which is the $4, times your quantity. So how many quantities you're going to sell is 50. Total profit's $200 in this example. It could be in hundreds of thousands of dollars, could be in millions of dollars, whatever it is. Now, one thing important to point out, we stressed before that a lot of firms want to try to work at this bottom out efficiency scale here on the average total cost curve. Well, if you did choose to work at this quantity, let's say it's 35 or 30, right here, you would actually be leaving this portion of the rectangle and profit on the table. So your marginal revenue at this point still exceeds your marginal cost, so you want to go get all that. Okay, you want to go get all that profit. Why would you leave that profit on the table when you have your competitive firm all set up and able to produce and obtain up until a point where marginal cost equals marginal revenue? So you wouldn't want to leave that profit on the table. So hopefully that clears that up. Okay, so now looking at identifying a firm's loss, determine this firm's total loss assuming average variable cost is less than 3. Okay, identify the area on the graph that represents the firm's loss. So you should note here that the statement assuming average variable cost is less than $3 is needed to prevent a shutdown. So to ensure the firm produces a quantity of 30 instead of a quantity of 0. So that was the one caveat in this scenario. So take a moment, examine that, pause the video, see if you can figure out the firm's total loss, and then we're going to move on to the answer. Okay. here we have an average total cost. We have our marginal revenues way down here, and marginal cost is right there. So we know we're not going to operate beyond where marginal cost equals marginal revenue because our costs are greater than our marginal revenue. All right. Well, here we have a problem with the average total cost is very high, or it's higher than our price. So our total loss is the average total cost minus price times quantity. So our average total cost minus price is $2. That's the $5 average total cost minus the price, which is $3. So that's $2 times our quantity, which is 30. So our total loss is 60. Okay, the height of the rectangle is ATC minus P, so average total cost minus price, which is the loss per unit. The width of the rectangle is Q, which is the number of units. The area of the rectangle is simply height times width, which is loss per unit times number of units, which is your total loss. Okay, again, this was assuming that we operate at a price of 3, which would prevent a shutdown. So there are scenarios where you might operate up until a point, again, to where marginal cost equals marginal revenue to minimize your loss. You can actually make back some of your money. Otherwise, your average total cost would be much greater in terms of this entire more vertical rectangle if you did not operate at all. So, market supply, let's make some assumptions. In the real world, there are many markets in which assumptions do not hold, such as 1 and 2. The first one, market assumption, is all existing firms and potential entrants have identical costs. Okay, that's not really all that realistic, but when we're setting the table for you to learn about competitive markets, it's easy to do it under a perfectly competitive market scenario where all existing firms and potential entrants have identical costs. You know that's not going to happen in the real world. And secondly, each firm's costs do not change as the other firms enter and exit the market. We know that's a little more fluid situation in the real world. So our market supply assumptions here are going to be all existing firms potential entrants have the identical costs, and each firm's costs do not change as the other firms enter and exit the market. And then thirdly, the number of firms in this market is fixed in the short run due to fixed costs, and variable in the long run due to free entry and exit. Now that one's a little more realistic. So in the real world, there are many markets in which assumptions 1 and 2 do not hold. We make them here for simplicity's sake. Later in the chapter, we'll see how our results change if we drop either of those assumptions. So assumption 3 is more reasonable. In the real world, it's much easier for firms to enter and exit in the long run than in the short run. Okay. So the short-run market supply curve, as long as price is greater than average variable costs, as long as your per unit revenue you're getting via price is greater than your per unit variable costs, each firm will produce its profit maximizing quantity where marginal revenue equals marginal cost. Again, if you're covering your variable costs in the short run, you're going to operate. So recall from chapter 4, at each price, the market quantity supplied is the sum of quantities supplied by all firms. So let's work through an example. Let's say we have 1,000 identical firms. Again, that's one of our assumptions. At each price, the quantity supplied equals 1,000 times one firm's quantity supplied. So you have 1,000 firms supplying the same quantity. So one firm here, we have a marginal cost curve, and we have these different prices which will represent marginal revenue. So at a price of 1, you produce 2. A price 2, you would produce 20. At price 3, you would produce 30. Again, those prices are synonymous with marginal revenue. That's where you would produce. So depending on the market price, you have this firm's scenario times 1,000, which makes up the entire market. Okay, so there's 1,000 different firms. They're all going to do what this one firm does. At price 3, the market's going to have 30,000. At price 2, it's going to produce a quantity of 20,000. At price 1, it's going to produce a quantity of 10,000. So identical means all firms have the same cost curves. You should note here that P1 is the minimum average variable cost. At any price below P1, each firm will shut down and the market quantity supplied will be 0. Hence, the market supply curve begins at price 1 and Q of 10,000. So entry and exit in the long run, the number of firms can change due to entry and exit, so movement in and out of the market. If existing firms earn a positive economic profit, new firms will enter. Short-run market supply shifts to the right. As new firms come in, there's more quantity being produced. Price falls, which reduces profits and slows entry. So if there's profit out there, Firms respond to incentives. They seek that profit. They'll seek it to a point that supply rises and price falls because things are more numerous or less valuable. And eventually it gets to a point where there are no more profits in that market to be had, or quite possibly firms start operating at a loss, so some firms that were on the fringe actually exit the market. So if existing firms incur losses, some firms will exit, short-run market supply shifts left, it's less available, price will begin to rise, which reduces remaining firms' losses. So it typically works toward an equilibrium where all of that profit is eked out of the market and no more firms enter the market. Now, there can be fluctuations either way. If there's more profit to be had, firms are going to enter. If there's less profits to be had, firms are going to leave. So the zero profit condition is the long-run equilibrium. That's the process of entry and exit. The process of entry and exit once complete, the remaining firms earn zero economic profit. Okay? The key word here is economic profit. All right? You would say, well, why would you stay in an industry where there's no profit? Well, you're thinking in terms of accounting profit. There still will be accounting a profit. There's just no incentive to continue to enter or exit that particular industry. So zero economic profit occurs when price equals average total cost. Since firms produce where price equals marginal revenue and where marginal revenue equals marginal cost, the zero profit condition then is where price equals marginal cost equals average total cost. Okay, all things being equal there. Recall that marginal cost intersects average total cost at the minimum average total cost. Hence, in the long run, we get back to that point where price equals the minimum average total cost, and that efficiency scope at the bottom of that average total cost curve. In the long run, things are going to move to where price equals that low point. Again, key point here, economic profit. There's still firms making an accounting profit, but economic profit is what entices firms to move into new industries, into new markets. Okay, if there's no economic profit there, they have no incentive to go seek that economic profit. All right. If there becomes a point where there's negative economic profit, where there's economic loss, then firms will leave that market. Okay, but in the long run, things moving back and forth between entry and exit, there's zero economic profit. There's plenty of accounting profit to be had. Okay, so why do firms stay in business if profit is zero? Again, hammer home this point. Recall, economic profit is revenue minus all costs, including implicit costs like opportunity cost of the owner's time and money. If there's zero profit, in the zero profit equilibrium, firms earn enough revenue to cover these costs, and accounting profit is positive. Again, there's the incentive of accounting profit still there. So I have a lot of students often wonder why firms bother to stay in business if they make zero profit. The textbook gives a nice discussion of this, and it's briefly summarized on this slide. So make sure you take a look at that in the reading again. And the key point is economic profit versus accounting profit. So the long-run market supply curve, in the long run, the typical firm earns zero profit, economic profit. Again, when we say profit in here, we're thinking economic profit. They're going to operate where marginal cost, which is synonymous here with price, equals marginal revenue. And in the long run, that's going to be at the very bottom of that long run average total cost curve. If you remember from the previous chapters, we had all the little short run average total cost curves that made up the long run average total cost curve. Well, the price is equal to the minimum average total cost curve in the long run. So the long run supply curve is going to be synonymous with price. So the long run market supply curve is horizontal at price, which is equal to average total cost. That the long run marginal total, the long run market supply curve is horizontal is indicative of price equal minimum average total cost in the long run. It will become more clear shortly. We're going to take a look at the short run and long run effects of an increase in demand, which will hopefully help to illustrate that a little better for you. So, this side replicates figure 8 from the textbook. Now, generally given in a class mode, all these little different boxes would pop up individually. Here we're going to have to sort through them one by one. The text box in the top part of the slide appear to be on top of each other in edit mode, which is how I do these lectures and present these lectures. But in the slideshow mode, the text boxes display one at a time. So this slide, hopefully by the time we're through it, will help you understand the market supply curve being horizontal. So give me a second. Let me slide these around. So in this example, we have one firm and we have the market. Okay, firms still operating where marginal cost equals marginal revenue. Okay, we have an increase of price from price 1 to price 2, and we have this area of profit. Again, initially marginal cost equals marginal revenue is at price 1, and marginal cost, which is at the minimum of the average total cost curve. So we know that's in the long run. A firm begins in the long run equilibrium here, P1 and MC. Leading to short-run profits for the firm. There's this profit area here. Drives, but then an increase in demand raises price to P2, okay, driving profits to 0, restoring the long-run equilibrium. So you have this fluctuation between price 1 and price 2. Okay, initially you have price 1. There's an increase in demand. Again, demand is not shown on this graph. So the market responds by providing more supply. They said, hey, there's an increased demand because there's this higher price. Price moved from P1 to P2, so we're going to increase supply. More firms are going to enter the market, and when more firms enter the market, more goods are produced. When more goods are more readily available, are they more valuable or less valuable? Well, we know when something's more abundant, it's less valuable, it's less scarce. So the price goes back down. Let's say in this example, it goes right back down to price 1. We're back to where we started. So over time, profits induce entry, shifting the supply to the right and reducing the price, which then reduces the economic profit that's available. So there's a dynamic situation here where you have some moving pieces where, let's say, initially price went up. That attracted more firms, which increased the supply, which in the long run reduced the price that firms can get because the good was more readily available, so price went down. So we ended up settling back into this average total cost curve where we were producing back at this minimum efficiency scale here. Okay, so in the short run, again, price can go up. Okay, it can move the marginal cost equals marginal revenue from this point here to here. Okay, because there's additional profit to be had. Initially, there was just this profit area here, if you can imagine a rectangle there. Well, when we moved up here, there was additional profit to be had. That additional economic profit attracted more firms, which increased the supply of the good, which in turn reduced the price, because if something's more widely available, it's not as expensive, and reduces the prices, and less firms are induced to enter the market. If it helps to give you a more common example, think about flat screen televisions. When they first came out, there were few suppliers. The price went up quickly. There was pretty good demand for it. However, over time, what happens? Supply increased. There were more suppliers in the market, which put downward pressure on flat screen TVs. LCDs, plasma, so on and so forth became much more available, much more widely available. We're already seeing some price decreases in 4K television technology because more have entered the market. This is the same thing you're seeing here graphically with supply coming in, which puts downward pressure back on that price, which reduces this in additional area of profit, which attracts other firms. So in the long run, we settle back in, we move back from this type of quantity back into a long run average total cost curve where we minimize the efficiency scale. All right, so why the long run supply curve might slope upward? The long run supply curve is horizontal if all firms have identical costs and costs do not change as other firms enter or exit the market. If either of these assumptions is not true, then the long run supply curve slopes upward. Now, here are the two assumptions that we made previously when we began the process of deriving the long run market supply curve that I told you are the least realistic in the real world. So that is why the long run supply curve slopes upward in real terms. So, number one, firms have different costs. As price rises, firms with lower costs enter the market before those with higher costs. Further increases in price make it worthwhile for higher cost firms to enter the market. It becomes more profitable for them to cover their costs, which increases the market quantity supplied. Hence, the long-run market supply curve slopes upward. At any price for the marginal firm, the price is equal to the minimum average total cost and profit equals zero. For lower cost firms, profit is greater than zero. So in the long run, if they're going to be in the market, the higher cost firms have to at least get to that minimum average total cost curve and have a zero economic profit to be in there in the long run. Now, lower cost firms, I should say, are going to have obviously lower costs, so greater profits. So profits greater than zero in the interim. Now, the marginal firm is the firm that would exit the market if the price were any lower. So they're kind of those fringe firms that would come and go. Now, costs rise as firms enter the market. This is that second assumption that we're kind of shooting holes in now. In some industries, the supply of a key input is limited. So, for example, the amount of land suitable for farming is fixed. There's only a certain amount of highly fertile land. The entry of new firms increases demand for this input, like more farming firms coming in, they're going to want more of the fertile land, causing its price to rise. So land becomes more expensive. This increases all firms' costs, say, to hold land. Hence, an increase in price is required to increase the market quantity supplied, so the supply curve is upward sloping. So the costs rise over the long run. Now, another example is there's a limited amount of beachfront property. An expansion of a beach resort industry will bid up the price of such property and raise the costs of the industry. So owning a beachfront home becomes more expensive, which may push you out of the market. So in conclusion, the efficiency of a competitive market, profit maximization occurs where marginal cost equals marginal revenue. Always remember that. Now, in perfect competition alone, price is equal to marginal revenue. So in a competitive equilibrium, that's the same as saying price equals marginal cost, because marginal cost equals marginal revenue. In perfect competition, price equals marginal revenue. So if marginal revenue equals marginal cost, then price must equal marginal cost as well. So recall, marginal cost is the cost of producing the marginal unit, one more unit. Price is the value to buyers of a marginal unit, the revenue they get from producing one more unit. Or actually, the value to the buyers is the value they get from obtaining one more unit. So the competitive equilibrium is efficient and maximizes total surplus. In the next chapter, we're going to cover monopoly, which is pricing and production decisions. We're going to look at a monopoly in terms of pricing and production decisions, deadweight loss, and regulation. So if you recall from Chapter 7, a competitive market equilibrium is efficient. This chapter has shown why price equals marginal revenue under perfect competition. Again, under perfect competition. So if marginal revenue if you want to operate with marginal revenue because marginal revenue equals marginal cost and price equals marginal revenue, you must also assume that price equals marginal cost, because marginal revenue is marginal cost, price equals marginal revenue, so price equals marginal cost. In a competitive equilibrium, perfect competition again. Reviewing these concepts now really sets the stage for the next few chapters, where firms with market power set the price above marginal cost because they can, they're a price setter. And that leads to market inefficiencies and a potential role for government intervention. So if you're lucky enough in your course to move on to looking at monopolies and oligopolies and monopolistic competition, we'll go deeper into that. So in summary, for a firm in a perfectly competitive market, again, this isn't always the case, a perfectly competitive market, price equals marginal revenue equals average revenue. So if price is greater than average variable cost, a firm maximizes profit by producing the quantity where marginal revenue equals marginal cost. If price is less than average variable cost, a firm will shut down in the short run. If you can't cover your variable costs, you need to shut down. If price is less than average total cost, a firm will exit the market in the long run. If you can't cover your average total cost in the long run, it's time for you to find something else to do. In the short run, entry is not possible, and an increase in demand increases the firm's profits. That's pretty straightforward. With free entry and exit, profits equals zero in the long run. That's, again, economic profits. That means there's no opportunity to make additional economic profits by shifting your business into a new industry. Okay, and price in the long run equals that minimal average total cost curve that efficiency scale point, that lowest point in the long run average total cost curve. That's where all roads lead in the long run. Listen, a ton of information on this lecture. Obviously, if you relied simply on the reading or simply on this lecture and didn't do the homework, or if you did the lecture and didn't do the reading, you're going to fall behind. Or if you did the reading and don't do the lecture, you're going to fall behind. And obviously, if you don't do the homework, you're not going to get credit for it. But please let me know if you have any questions about any particular things here. There's a lot of work to be done in this chapter, but I promise you, if you set the foundation of around competitive markets, it will make your life much easier moving forward and give you insights that will be very valuable. If you have any questions, email's best. Send me an email. We can set up a time to talk, and please let me know if you have any questions. Thank you.